So hey everyone, I welcome you all to the SkillSharp, and today we are going to see bitwise operators in Python programming language. So what is the bitwise operator? As we have saw in previous lectures, operators perform operations on the operands. So here in our case, bitwise operator perform operation on bits or bit by bit value. If we provide integer to it, then it will perform operations on integers. So let's start it. So here you can see our first operator is bitwise AND operator, and it is represented by the ampersand symbol. On your laptop's keyboard it is on the number 7. You can access it by shift and 7. So you can see if operand 1 is 0 and operand 2 is 0, then bitwise AND will return 0. If operand 1 is 1 and operand 2 is 0, then it will return 0. In operand 1 is 0, operand 2 is 1, then it will return 0. Only operand 1 and 2 both are 1, then it will return 1. So this is the truth table of bitwise AND. One important thing here, I have created one variable a equals to 4, and if I want to convert this variable to binary just to show you, then you can see here this is the binary representation of 1, that is 001B0, and it can be represented in this way as well. So this is the binary value of 4. Our second variable is b and its binary value is 101. So now let's perform the operation. So 4 is represented like this and 5 is represented like this in binary. So let's perform the bitwise and you can see our what will be our result. So 0 and 1, it will return to 0, 0 and 0, it will return 0, 1 and 1, it will return 1. So 100 is our final binary result after performing bitwise and 100 is converted to 4. So let's perform the operation and let's see. So you can see a and b is 4, and now you can see a's value is 4 and b's value is 5. So this is the bitwise and. Our second bitwise operator is bitwise OR operator, and it is represented by this pipe symbol. And this symbol is on your keyboard above the enter key. By clicking the shift, you can access this symbol. The truth table of bitwise OR is, you can see here, this is the truth table of bitwise OR. It will always true only if both the operands are 0, it will return 0 or false. So here this is the bitwise OR. Let's try to perform the bitwise OR operation. Now you can see A or B is 5. So how this come to 5? As we know, A has value 4 and B has value 5. So this is the binary representation of A and this is binary representation of B. So let's do it. 0 or 1, it will return 1. 0 or 0, it will return 0. 1 or 1, it will return 1. You can use this truth table as well. So now you can see A or B's binary representation is this 101, and when we convert it to integer, then we will get the value of 5. Our next operator or next bitwise operator is bitwise XOR or bitwise XOR operator, and this is the truth table or bitwise XOR operator. It is also known as exclusive OR operator, and it will return the value as 1 if any one operand from both the operand is 1. Otherwise it will return 0, you can see in the truth table. So here I will perform bitwise OR operation. So here you can see A XOR B. So let's do the analysis how it comes. So A has value 4 and its binary representation is 100. B has value 5 and its binary representation is 101. Now A XOR B, 0 XOR 1. So 0 XOR 1 is 1. So 1. 0 XOR 0 is 0. So 0. 1 XOR 1 is 0. So 0. So here a XOR B is 001, and when you convert to it integer, then it will return 1. That's why we got the value as 1. Then our next bitwise operator is bitwise NOT operator or negation operator, and it's a unary operator. Why? because it only need one operand, and it will reverse the value or polarity of the operand. If your operand has 0, then it will convert it to 1, and if it is 1, then it will convert it to 0. So here, as we all know, we have value of a, and a's value is 4, and 4 is represented like this. Okay, so what if we convert it to with this? So now you can see it represented as minus 5, but if we convert it 0, 0 will convert it to 1, 0 will be converted to 1, 1 will be converted to 0, then it should be 3, right? But it is not 3, it returns minus 5. And why it is so? Let's investigate. So here you can see when I perform the bitwise NOT operation, then it will convert it to this. But one more important thing, every number we stored, it has one bit or signed bit at the starting or at the beginning. It represents the sign of the value. If it is 0, then it is positive number, and if it is 1, then it is negative number. Okay. So while performing negation operation, it converts like this. 0 is converted to 1, 0 is converted to 1, 1 converted to 0, and sign bit 0 is converted to 1. Then it should be minus 3, right? But no. In programming language like Python, C++, we store negative number in 2's complement form. So we have to convert these numbers 2's complement. That's why let's convert it. So how we can convert it to 2's complement? For that, first of all, we have to reverse the bits again. So 1 is converted to 0, then this one is converted to 0, then this 0 is converted to 1. And here we are not converting the sign bit. So 1 is kept as 1. Okay. So this is the number. This is the 1's complement. And we have to add 1 to the first bit of it. So that's why 0 plus 1 is 1, 0 comes to 0, 1 comes to 1, and bit and sign bit 1 comes to 1. So this is the final 2's complement form of this number. And so we have minus 5 because this 1 has value 1, 2 to the power 0. This 0 has value 2 to the power 1, that's why 0 into 0, that's why 0, and this 1 has value 1 into 2 to the power 1. 1 into 2 to the power 2, that has value 4. So 4 plus 1, and its sign is minus 1. So that's why we got minus 5. So this is the bitwise NOT operator. Okay. Then our next is bitwise left shift operator. So what is the bitwise left shift operator? So as we all know, a has value 4, right? And 4 can be represented like this: 0 0 1 0 0 0 0 0, right? So what this left shift operator do, it will shift the bits by two places. So you can see here. So now this one will be shifted at this, and after that it will be shifted at this place, right? And after completing the operation by shifting the bits with 2, we get this value, right? And you can see this value has 2 to the power 0 into 0, 2 to the power 1 into 0, 2 to the power 2 into 0, 2 to the power 3 into 0, and 2 to the power 4 into 1. So its value come to 16. And that's why when we run this left shift, a left shift 2, we get 16 or positive 16. So this is the bitwise left shift operator. Then bitwise right shift operator, it does the same operation in opposite direction. It will shift the bits with two places, and if you change this 2 to 3, then it will shift with three places. Okay, so here you can see a has value 4, and whose binary representation is this. So we have to shift every bit with two places. So this 0 is shifted and truncated, this 0 is shifted with two places and truncated, then this 1 is shifted with two places. So this is the first and this is the second. So here it comes, and every 0 is shifted then two places and add new two zeros. Okay, so that's why our final a right shift 2 is this. Okay, and that's why its value should be 1. So because 2 to the power 0 into 1 is 1, and all are zeros, so There is nothing to add. So let's see. So now you can see this value is 1. So these are the bitwise operators in Python programming language. I hope you understood this lecture. If you have any question related to the bitwise operator, then feel free to ask the questions in the comment section below. I will see you in the next lecture. And if you haven't subscribed this channel, then subscribe it, like, share and comment. We will see you in the next video. Till then, happy coding.